This is section 1D, part 5. Sorry, I thought I was done in the last video and realized I have one more page to go. So we had just been talking about finding limits for piecewise defined functions. And we need to talk about finding a limit for an absolute value function. The reason we do that right now is that an absolute value function is actually just sort of like a piecewise function in disguise. We all know that the absolute value makes everything positive, right? That's sort of the simplest definition of absolute value. So in fact, what I could do here is I could write this as two separate functions. Let's just say that this function here is f of x for right now. And what I could say is that what's inside the absolute value, x minus 2, is already positive. If that's already positive, then the absolute value really isn't going to change it. So I can just drop the absolute values as long as x is bigger than 2, right? That's going to make that positive. If x is less than 2, what's inside the absolute values will be negative. And in that case, the absolute value does change the sign and make it positive. So I'll end up with the opposite of x minus 2 over 2x minus 4. And that's going to happen anytime x is less than 2. What's inside the parentheses would be negative. The absolute value changes that sign and makes it positive. Right at x equals 2, of course, we've got a problem because that's going to put a 0 in the denominator. So I'm not going to worry about that right now. We'll deal with that when we actually do the limit. All right, let's work on simplifying this just a little bit. I could factor the 2 out here. And then I'll be able to reduce, just cancel out those x minus 2's. And kind of the same thing on the second one. I can factor the 2 out. So when I get down to my really simplified form, I'll just have 1/2 when x is greater than 2, and negative 1/2 when x is less than 2. So that one's simplified a lot. They just don't both turn into constants. That won't always happen. But this idea of rewriting an absolute value with dropping the absolute values when what's inside is positive and changing the sign when what's inside is negative is going to work on every absolute value problem with a limit. All right, I'm ready to do this limit now. And since I am looking at a limit as we're approaching the break point in the domain, I'm going to rewrite this in terms of two one-sided limits. And I'm going to say the limit as x approaches 2 from the left, that would be numbers smaller than 2, I'd be using this function. So the function is already negative 1/2, and I'll just get negative 1/2. Nothing to really even plug in there. The limit as x approaches 2 from the right, so numbers bigger than 2, my function is simplified to just positive 1/2. And so the limit again is just positive 1/2. Nothing to plug in. So the limits from each side are not the same, meaning that my original limit, the two-sided limit, does not exist. So anytime you're stuck with an absolute value, you want to rewrite it as a piecewise function, and then you can do the one-sided limits to determine the final answer. All right, one other mention about one-sided limits. Sometimes limits are one-sided because the function actually only exists on one side due to its domain. Here's an example of that. We've got the limit as x approaches 3 from the right of the square root of x minus 3. Of course, if numbers are smaller than 3, we'd have a negative under the radical, and we would not have a real valued answer at all. So in fact, it's impossible to approach from the left in a situation like this. Indeed, I'll use my typical technique of just saying, can we plug in the value? And of course, in this case, we can. We just get 0. And we're done. But I mention that only because I don't want you to make too much of the fact that that limit was from the right. It's strictly because of the original function's domain. All right, now we truly are done with section 1D.